A very good morning to all of you. I am Dr. Naveen Kumar Devangan, Professor in the Department of Electronics and Telecommunication Engineering, Bhilai Institute of Technology, Durg. It is a great pleasure to be here today with you all and talk about the exciting world of biomedical instrumentation and sensors in the fascinating realm of blood pressure measurement. First of all, we will start with concepts of blood pressure. Here we will see how blood pressure is developed at different sites of the body due to pumping activity of the heart. We will see the concept of systolic pressure, diastolic pressure, pulse and mean arterial pressure along with their normal values. Then we will also cover categories of blood pressure. We will see the cases of normal blood pressure, elevated blood pressure, high blood pressure, case of hypertension, stage 1, high blood pressure, case of hypertension, case 2. Then we will also cover categories of blood pressure. We will see cases of normal blood pressure, elevated blood pressure, high blood pressure, cases of hypertension stage 1, high blood pressure, hypertension case stage 2, and then hypotensive crisis, consult your doctor immediately case. Then we will move to measuring and monitoring blood pressure. We will see how blood pressure is measured and monitored at different sites of the body. There are two methods of blood pressure measurements, each method having own advantages and disadvantages. First, we will cover indirect method of blood pressure measurements with its advantages and disadvantages. Then direct method with its advantages and disadvantages. Now we are going to see the concept of blood pressure. You might have studied how electrical activity of the heart is responsible for the pumping activity of the heart muscle. The heart is the pump responsible for maintaining adequate circulation of oxygenated blood around the vascular network of the body. It is a 4-chamber pump with the right side receiving deoxygenated blood from the body at a low pressure and pumping it to the lungs. The circulatory path we call it as pulmonary circulation, and the left side receiving oxygenated blood from the lungs and pumping it at high pressure around the body. The circulation path we call the systemic circulation. Blood is pumped by the left side of the heart into the aorta, which supplies it to the arterial circuit. Due to the load resistance of the arterioles and precapillaries, it loses most of its pressure and returns to the heart at a low pressure via highly distensible veins. The right side of the heart pumps it to the pulmonary circuit, which operates at a lower pressure. The heart supplies blood to both circuits as simultaneous intermittent flow pulses of variable rate and volume. The maximum pressure reached during cardiac ejection when heart contracts is called systolic pressure, and the minimum pressure occurring at the end of a ventricular relaxation is dubbed as diastolic pressure. The mean arterial pressure over one cardiac cycle is approximated by adding 1/3 of the pulse pressure to the diastolic pressure. Pulse pressure is nothing but the difference of systolic and diastolic pressure. Now let us find the range of blood pressure developed in the circularly path. Remember, all blood pressure measurements are made with reference to the atmospheric pressure. Blood pressure is measured in millimeter of mercury, that is mmHg. A blood pressure measurement has two numbers, upper number and lower number. Upper number represents systolic pressure and lower number represents diastolic pressure. Why it is important to measure blood pressure? Because high value increases the risk of heart attack, while low value increases the risk of lower oxygen perfusion, for example in the brains. However, the normal values of blood pressure differ from person to person. In arterial system, pressure range varies from 30 mmHg to 300 mmHg, and in venous system blood pressure varies from 5 mmHg to 15 mmHg, and in pulmonary system blood pressure varies from 6 mmHg to 25 mmHg, while mean pressure is rather uniform throughout the vascular system. Systolic pressure and diastolic pressure can vary dramatically in normal situations. Now we are going to define three types of blood pressure: systolic, diastolic and mean blood pressure. Systolic pressure is the maximum pressure reached during cardiac ejection when ventricle contracts. It varies in normal cases from 95 mmHg to 140 mmHg, with 120 mmHg being taken average, while diastolic pressure is the minimum pressure that occurs at the end of ventricular relaxation and varies from 60 mmHg to 90 mmHg, with 80 mmHg being average. Mean pressure is defined as average pressure during one cardiac cycle, and its estimate can be made by using an empirical formula. Mean pressure can be written as equal to diastolic pressure plus 1/3 of pulse pressure. Now we are going to see the blood pressure categories: normal, elevated, high blood pressure, hypertension stage 1, high blood pressure, hypertension stage 2 and hypertensive, consult the doctor stage case. In the table you can see that for normal case systolic pressure is less than 120 mmHg, while diastolic pressure is less than 80 mmHg. In case of elevated blood pressure, the systolic pressure is in between 120 and 129 mmHg, while diastolic pressure is less than 80 mmHg. High blood pressure, hypertension stage 1 case, systolic pressure is in between 130 and 139 mmHg, while diastolic pressure is in between 80 and 89 mmHg. In case of high blood pressure, hypertension stage 1, systolic pressure is 140 or higher mmHg and diastolic pressure is 90 or higher mmHg. In case of hypertensive crisis, consult your doctor case. Systolic pressure is more than 180 mmHg, while diastolic pressure is higher than 120 mmHg. Now we will see how blood pressure developed due to pumping activity of the heart is measured. The most frequent monitored pressures which have clinical usefulness in medium and long term patient monitoring are the arterial pressure and the venous pressure. There are two basic methods for measuring blood pressure: direct method and indirect method. The indirect method consists of simple equipment and cause very little discomfort to the subject, but they are intermittent and less informative. They are based on the adjustment of a known external pressure equal to the vascular pressure so that the vessel just collapses. On the other hand, direct methods provides continuous and much more reliable information about the absolute vascular pressure from probes or transducers inserted directly into the blood stream. But the additional information is obtained at the cost of increased disturbance to the patient and complexity of the equipment. Blood pressure readings vary with subjects and among other variables with the location of the transducer. If manometric blood pressure readings are not taken at heart level, they should be compensated to correspond to the readings at heart level. For example, if a mercury manometer reading is taken at h millimeter below heart level, the reading is high due to the weight of a column of blood h millimeter high. This weight is rho gh. The compensation factor is simply the ratio of densities of mercury and blood, that is 12.9. So the equivalent reading at heart level is thus millimeter Hg reading is equal to millimeter above or below heart level divided by 12.9. If the manometer is above the heart level, add the correction, and if it is below, subtract the correction. Now let us see indirect method of blood pressure measurement. Indirect methods are non-invasive measurements. Indirect method has simple equipment and does not put the subject any discomfort. Blood pressure is measured by means of sphygmomanometer. With indirect method, it is only possible to obtain systolic and diastolic arterial pressure readings. The pressure waveform is not displayed. Indirect method is also subjective. The classical method of making an indirect measurement of blood pressure is by the use of a cuff over the limb containing the artery. Initially, the pressure in the cuff is raised to a level well above the systolic pressure so that the flow of blood is completely terminated. Pressure in the cuff is then released at a particular rate. When it reaches a level which is below the systolic pressure, a brief flow occurs. If the cuff pressure is allowed to fall further just below the diastolic pressure value, the flow becomes normal and uninterrupted. The problem here finally reduces to determining the exact instant at which the artery just opens and when it is fully opened. The method is given by Korotkov and based on the sounds produced by flow changes is the one normally used in the conventional sphygmomanometers. Now we will see some general facts related to blood pressure measurement. Brachial artery is the most common measurement site close to the heart and is convenient for the blood pressure measurement. Other sites for blood pressure measurements are forearm, radial artery and wrist. The most common indirect methods of blood pressure measurements are auscultation and oscillometry. Now we are going to see different indirect methods of blood pressure measurements. First method is auscultatory method of sphygmomanometer. As this is an indirect method, so the measurement is non-invasive. This method makes use of the fact that the noise emitted by the artery changes. The blood pressure is measured by the use of a cuff over the limb containing the artery. Initially, the pressure in the cuff is raised to a level well above the systolic pressure so that the flow of blood is completely terminated. The doctor, using a stethoscope or a microphone that replaces the ears, cannot hear any noise while the artery is compressed. The artery then begins to make noise as the pressure in the cuff is lowered, and the pressure measured by the instrument at that point determines the maximum blood pressure or systolic blood pressure. The noise then persists as the pressure in the cuff is reduced until the noise stops, at which point the pressure displayed on the device determines the minimal blood pressure or diastolic pressure. It is used by the doctor as well as a device that automatically measures blood pressure. The given figure illustrates the auscultatory method of sphygmomanometer. You can see when the pressure in the cuff is deflated, noise is started at a point when the pressure in the cuff is equal to the value of systolic pressure of the blood. From given figure, we can also see that the noise generated is continued to be heard up to the diastolic pressure, giving the value of diastolic pressure reading in the sphygmomanometer at that instant when noise disappears. Hollow pipes transmit the pressure in the cuff to a system that will provide a legible blood pressure reading. There are several devices on the market right now, including one that use a metal membrane and a mercury column. We have option of sphygmomanometer with mercury. This device has a mercury column that can be used to measure blood pressure. The millimeter of mercury, that is mmHg, is the blood pressure measurement unit because this method is the oldest. This approach has served as the standard technique for measuring blood pressure till Now, this particular sphygmometer is used just to monitor blood pressure at the level of the arm. Now, coming to the advantages of auscultatory method. This method is simple and minimal equipments are needed for the auscultatory procedure. Now, we see the disadvantages of auscultatory method. In a noisy environment, auscultatory technique cannot be used. The observations vary depending on the observer, so we can say subjectivity arises in the reading of manometer because you have to note down the reading of mercury column in the same instant when chorotoscope sound appears and disappears. Another disadvantage is that a mechanical fault such as a mercury leak, an air leak, a cuff obstruction, etc. could enter the system. The measurements don't always match the intra-arterial pressure. For babies and individuals with low blood pressure, this approach does not provide reliable results. So, another option which replaces mercury column is anuride sphygmomanometer, which is shown in the figure. This particular device is mercury free. The blood pressure transmitted by the cuff is translated by a metal membrane inside a casing. If it is routinely controlled, this type of equipment is very convenient to operate and generally reliable. This technique is a good replacement for the mercury filled sphygmomanometer, which will be phased out in a few years. This device may measure blood pressure at the wrist or finger level in addition to the arm level. Now, coming to second indirect method, that is palpatory method. In this method, instead of hearing the chorotoscope sounds, the doctor feels the patient's pulse downstream from the blood pressure cuff to identify the blood flow in the artery. The wrist pulse can be felt when the cuff is deflated, so pressure in the cuff when pulse starts is given as systolic pressure, that is the blood pressure of the blood. Advantages of this method are that even in a noisy atmosphere, blood pressure may be measured. Another advantage with this technique is that it does not need a lot of equipment. Now, coming to the disadvantages of palpatory method. Palpatory method measures only the systolic pressure but not diastolic pressure. For babies and individuals with low blood pressure, the approach does not provide accurate results. Now, coming to third indirect method of blood pressure measurement, that is oscillometric method. In oscillometric method, the intra-arterial pulsation is transmitted via cuff to the transducer. For example, transducer is generally taken piezoelectric transducer. The cuff pressure is deflated either linearly or stepwise. The oscillation in arterial pressure are superimposed on the cuff pressure. Diastolic pressure and systolic pressure are calculated using an empirical algorithm from the oscillation's amplitude. In the given figure, we can see that when the pressure in the cuff is deflated, the first major oscillation will start when the pressure in the cuff is equal to the systolic pressure of the blood. So, the first major oscillation represents the upper number of the pressure, that is systolic pressure. In the same figure, we can see that last major oscillation will represent the lower value of blood pressure, that is diastolic pressure, and the highest oscillation will give the value of mean arterial pressure. So, with this method, we can measure systolic pressure, diastolic pressure and mean arterial pressure, three significant values of blood pressure. Now, coming to the advantages of this method, on the recent years, oscillometric methods have become popular for their simplicity of use and reliability. Mean pressure can be measured reliably even in the case of hypotension case. Disadvantage of this method is that Many devices use fixed algorithms leading to large variance in blood pressures. With this, we have covered all three main indirect method of blood pressure measurement. Next, we will see direct method of blood pressure measurement. The direct method of pressure measurement is used when the highest degree of absolute accuracy, dynamic response, and continuous monitoring are required. Direct method is more accurate than indirect methods. They provide a continuous readout or recording of the blood pressure waveform. However, direct methods necessitate puncturing of blood vessels. The patient will be more disturbed and the equipment will be more complicated. The direct method is also used to measure the pressure in deep regions inaccessible by indirect means. For direct measurement, a catheter or a needle type probe is inserted through a vein or artery to the area of interest. Measurement of blood pressure by the direct method, though an invasive technique, gives not only the systolic, diastolic, and mean pressures but also a visualization of the pulse contour and such information as stroke volume, duration of systole, ejection time, and other variables. Once an arterial catheter is in place, it is also convenient for drawing blood samples to determine the cardiac output, blood gases, and other chemistries. The direct measurement of blood pressure is usually obtained by one of the three methods. First method is percutaneous insertion, second method is catheterization, we call it as also vessel cut down method. Then third method is implantation of a transducer in a vessel or in the heart. Coming to the first direct method, that is percutaneous insertion method. In this method, a needle is used to measure blood pressure in the vascular just beneath the skin. A hollow needle is inserted toward the vessel at a modest angle. A catheter is fed into the hollow needle once it has been inserted, typically with some kind of guidance. The needle and guides are removed once the catheter is firmly placed in the vessel. The catheter tip has a suitable transducer integrated into it, and the transducer converts pressure waveform into the electrical signal. This electrical signal is further processed to display the continuous recording of the pulse waveform. Then coming to the second direct method, that is catheterization vessel cut down method. This method has two options. In option A, a catheterization method involving the sensing of blood pressure through a liquid column. This technique involves a transducer that is exterior to the body, which receives the blood pressure via a catheter and a saline solution column. An LVDT or an unbounded resistance strain gauge can be used in this technique to measure the pressure. Before inserting the catheter into the blood vessel, it is important that the fluid filled system should be thoroughly flushed. In practice, a steady flow of sterile saline is passed through the catheter to prevent blood clotting in it. As air bubbles dampen the frequency response of the system, it should be ensured that the system is free from them. Now coming to the second option, in second option, that a procedure that involves inserting a catheter based transducer at the actual site of measurement in the bloodstream, for example into the aorta, by mounting the transducer on the tip of the catheter. We need more elaboration of option A, that is catheterization method involving the sensing of blood pressure through a liquid column. Given figure illustrates the use of catheterization method involving the sensing of blood pressure through a liquid column. In the given figure, you can see how the blood pressure at heart is transmitted to the transducer using a liquid column. The transducer converts these pressure oscillations into electrical energy. Available electrical signal is then filtered amplified for display of the pressure waveform in the suitable way. Given figure shows a simplified circuit diagram commonly used for processing the electrical signals received from the pressure transducer for the measurement of arterial pressure. The transducer is excited with a 5 volt DC excitation. The electrical signal corresponding to the arterial pressure obtained by the transducer are amplified in an operational amplifier or a carrier amplifier. The modern preamplifier for processing pressure signals are of the isolated type and therefore comprise of floating and grounded circuits similar to ECG amplifiers. The excitation for the transducer comes from an amplitude controlled bridge oscillator through an isolating transformer which provide an interconnection between the floating and grounded circuits. An additional secondary winding in the transformer is used to obtain isolated power supply for the floating circuits. The input stage is a differential circuit which amplifies pressure change which is sensed in the patient connected circuit. The gain of the amplifier can be adjusted depending upon the sensitivity of the transducer. After RF filtering, the signal is transformer coupled to a synchronized demodulator for removing the carrier frequency from the pressure signal. For the measurement of systolic pressure, a conventional peak reading type meter is used. When a positive going pressure pulse appears at point A, diode D3 conducts and charges capacitor C3 to the peak value of the input signal which corresponds to the systolic value. Time constant R3C3 is chosen in such a way that it gives a steady output to the indicating meter. The value of diastolic pressure is derived in an indirect way. A clamping circuit consisting of capacitor C1 and diode D1 is used to develop a voltage equal to the peak to peak value of the pulse pressure. This voltage appears across resistor R1. Diode D2 would then conduct and charge capacitor C2 to the peak value of the pulse signal. The diastolic pressure is indicated by a second meter M2 which shows the difference between the peak systolic minus the peak to peak pulse pressure signal. The mean arterial pressure can also be read by using a smoothing circuit when required. The third direct method and last method is implantation technique. In this method, by using surgical techniques, the transducer is more firmly implanted in the blood vessel or the heart. So, these are some of the popular techniques of blood pressure measurement. So, in today's lecture, we have seen concept of blood pressure. We have also seen why it is important to measure blood pressure. We have also seen various categories of blood pressure. We have also seen what is systolic pressure, diastolic pressure and mean arterial pressure. We have also covered the popular methods of blood pressure measurements along with their advantages and disadvantages. Finally, I am revising the topic blood pressure measurement in a few sentences. Blood pressure arises due to the pumping activity of the heart. Proper values of blood pressure is important for the health of the body tissues and muscles. Higher values tends to bring the heart attack and lower value may be responsible for low oxygen perfusion, for example in the brain. Systolic pressure is the maximum pressure developed in the arterial system when heart contracts, and the diastolic pressure is the minimum pressure developed during ventricle relaxation. Systolic pressure normal value is taken 120 mmHg and the diastolic pressure normal value is taken 80 mmHg. Indirect methods are simple and cause no discomfort to the patient, but only systolic pressure, diastolic pressure and mean arterial pressure can be measured. While the direct methods are more complex, vessels are to be punctured, but continuous monitoring of blood pressure waveform is possible with direct method. Blood pressure is the most often measured and the most intensively studied parameter in medical and physiological practice. The determination of only its maximum and minimum levels during each cardiac cycle, supplemented by information about other physiological parameters, is an invaluable diagnostic aid to assess the vascular condition and certain other aspects of cardiac performance. Pressure measurements are a vital indication in the successful treatment and management of critically ill patients in an intensive cardiac care or of patients undergoing cardiac catheterization. The tremendous research and development for an automatic blood pressure monitor has resulted in several methods. Blood pressure is the most often measured and the most intensively studied parameter in medical and physiological practice. The determination of only its maximum and minimum levels during each cardiac cycle, supplemented by information about other physiological parameters, is an invaluable diagnostic aid to assess the vascular condition and certain other aspects of cardiac performance. Pressure measurements are a vital indication in the successful treatment and management of critically ill patients in an intensive cardiac care or of patients undergoing cardiac catheterization. The tremendous research and development for an automatic blood pressure monitor has resulted in several methods, but only very few have been commercialized due to certain practical difficulties. Now, briefly summarizing important topics of blood pressure measurement, that you should know what is systolic pressure, diastolic pressure, mean arterial pressure, and why it is important to measure blood pressure. Then you must also remember the various categories of blood pressure. Then two important methods, indirect method and direct method, each are having their own advantages and disadvantages method. Generally, indirect methods are used because these methods are simple and easy to use, but with this method, as you have seen, we can only measure systolic pressure and diastolic pressure. In certain method, we can measure also mean arterial pressure. So, direct method is prepared when continuous waveform is desired, and apart from these three values of blood pressure, other parameters are also desirable, but they need puncturing of the blood vessel, so the system is more complex and cause discomfort to the patient also. So, with this I complete my today's lecture. If you need any further information and any clarification, feel free to contact me through my mail naveen.devangan@bitdurg.ac.in. In my next lecture, I will be available with another interesting topic of biomedical instrumentation and sensors. Till then, goodbye. Thank you all.